Good evening, ladies and gentlemen. I'm playing with junk again. I built my own multimedia center here, and maybe the case may seem familiar to you. It's a 10-year-old Thermaltake media PC case with a built-in LCD display, some buttons and nice round knob and a push door here and space for a CD drive that sometimes comes out. I want to talk a little bit about this case and what I have done with it, and I want especially talk about this thing here, which has an USB connector, some kind of a weird board with a blob chip here and two wires attached, and probably this thing is more interesting than this thing. So that's the Thermaltake DH-102. DH stands for Digital Home, and this was the hot case 10 years ago for everyone who wanted to build a home music entertainment center. It's a more or less standard PC case with a built-in 8-inch screen, and that's how it looks inside. I basically made it empty. I removed the main board because I thought it's not necessary to have a 50-watt consuming CPU here on the main board just to play some music or some videos or stuff. I put in a Raspberry Pi. It's the Model 4B with a 30 gigabyte SD card, micro SD card. Probably I will also add an SSD drive. I'm playing with that at the moment. I haven't figured out how I can properly connect it to the KODI that works in this Raspberry here. KODI, for those who are not familiar with it, it's a media center software that is free, runs on Windows, Mac, Raspberry, almost everything can be installed on the Windows or here on the Raspberry. Well, it's almost working alone. I will show you that a little bit later. The first problem was with this case, not that it's already 10 years old, that's not a big problem, but the original display here was great, but the touch interface was horrible, because normally you would expect a touch interface has a USB plug, which it had, and it would emulate a mouse, so you plug it in, touch around like this, and it works. But the original display had a special customized chip, and that needed a special customized driver, and that driver is almost impossible to get now, 10 years after the display or after this case came out. And in case if you can find it, it's certainly only for Windows XP or something and doesn't work with KODI, and well, I just fitted another display in it. So this display comes from AliExpress. It's a 8-inch display. It has touch interface. The display is connected by HDMI, goes directly to the Raspberry Pi, and the touch is connected by USB, which is also powering the entire display. So you only need that USB connector, 5 volt, about 1 half an amp, maybe 1 amp, and you're fine with the display. And that's how the display looks from the back side. So you can flip the entire front here down. It has 3 clips. You see the HDMI connector, the USB connector, and a second USB connector, which has exactly the same properties as the first. So I don't know why they installed 2 USB connectors. Don't know, maybe it's a practical reason for that. Then we have the keys from the front panel. They are not connected yet. That's when this thing comes into action. And that's the Rotary Encoder, which I will replace with a normal analog stereo potentiometer to make the sound loud or soft. Okay, what else? We have the standard PC power supply, which is really a silent one, so I keep that inside. It also closes the big hole on the back side. And as you can see, the display is just glued in with hot glue. I know that's a quick and dirty option. And here is a power switch that goes to the green and black wire of the power supply, connects them together, power supply starts working, everything is fine. CD drive has an adapter here that converts it into USB. That's how it is connected to the Raspberry. CD drive works fine. The only problem is it's very loud. It has some mechanical vibrations on every CD I played until now. Or I use it to rip CDs, because when I play CDs, CD turn slower. And when you rip CDs, it runs at full speed, reads the data, puts it on the SD card, and that makes some noise because of vibrations. So I have to change that CD drive. And another issue is that the drawer here doesn't open all the time. It's an old CD drive, it's an old case, everything is old except the Raspberry and the display. And the whole cost for the entire setup here, which is working right now, well, it's not working right now, I switched it off. It's the whole cost, it's about $100. So I have to say I got the original case here for free. Display is about $50. Raspberry Pi with 4 GB RAM is also about $50, so let's say 100. If you have to buy the case too, maybe you're lucky, you get one for, I don't know, 20, 30 bucks. Or you build your own case, which makes probably a little bit more sense, because this case here is way oversized for the tiny little Raspberry. You can see there is a lot of space, but well, maybe I have 1 or 2 ideas and maybe it gets a little bit more crowded. As you have seen in the startup sequence here, this device runs on LibreELEC, that's the operating system, and KODI is the software for the media center. And to install this on a Raspberry Pi, that's the easiest thing to do. You just download Noops from the Raspberry Pi website, which is free and it's easy to find. You copy that stuff on your SD card, and when you power up the Raspberry for the first time, you are asked to choose the operating system. You can install Raspbian or LibreELEC, and if you choose LibreELEC, it also installs KODI automatically, and it removes all the files you don't need from the SD card, and at the end you have a very slender operating system with only the few parts you need to use KODI. So that's the easiest way, and I must say everything works, because I tried it first with DietPi and KODI, and there are some things I had problems with the display resolution. To set it correctly, it didn't work on that display, and if I reduced the resolution, KODI didn't work, and with this combination here, everything works like a charm. But there are certain problems with KODI itself. The problem is, or one of the problems is, if I select music and I go to songs and I choose for something from AC/DC, and I go back and choose the full screen animation here. The problem is there is no way to get back to this, to the first. Well, sometimes it works, but no, that's not what I want. Yeah, you could double tap it with 2 fingers. That's the same as a right click with the mouse. Then you get the menu, but if you go back, go back. Okay. Maybe like that. No. So I'm still in this full screen animation setup here, and there is no way to go back except you take your keyboard and press the escape button. Then you come back to the normal menu. Music is still playing. You can, of course, escape this screen here by stopping the music. That also leads you back to this menu, but I don't want to stop my music. I want to continue listening and browse through my genres and albums and stuff. So I need an escape button here or here. And I also want this arrow buttons, up, down, left, right, working. So I came up with the idea to cannibalize an old keyboard. So that's a keyboard controller from a Logitech Slimline or extra slim keyboard. I think that was how it's called. I don't remember the exact type, but I think similar keyboard interfaces can be found in any keyboard. Here you see 2 connectors. One is for the rows of keys and the other one for the column of keys. Well, maybe at first we have to do some keyboard theory. How does a keyboard work? A normal keyboard, or maybe even this one, has, I don't know, 100 keys. So a usual number is 104 keys. That's a standard full-size keyboard with a keypad with some extra keys, function keys, and so on. But there are keyboards with more keys, with less keys, or even with the integrated touch panel. Oh, I have to turn it off or it will drain the batteries. And well, of course, you don't you need some sort of chip that converts it for USB, PS2, serial, or whatever interface you need. And of course, if you have 100 and something keys, you don't want to connect every single key with 2 wires, because that would give you 200 or 300 wires to connect somewhere. You make it a little bit simpler. You connect all the rows together and you connect all the columns with 1 wire each. And if you press one of the buttons, there is the switch. You connect this line with this line. So let's say you have 1, 2, 3, 4 columns by 1, 2, 3, 4, 5, 6, 7, 8. 4 rows and 8 columns. Okay, that's 32 keys, and you only need 8, 9, 10, 11, 12 wires. 12 wires for 32 keys. That's not bad. And that's exactly how it is done here. The smaller connector are the rows of the keyboard. Normally you have 1, 2, 3, 4, 5, maybe 6 rows. This one has 8 connectors, 8 pins here. And you have about 20 keys in length. So this one has, I think it was 18, yes. Let me put that in. Yes, J2 is 18 pins and the other one is 8 pins. I hope you can see that. That was not meant to be on camera here. So what I did was I plugged this into my PC, and there are some keyboard test programs online. You can search Google for that, keyboard tester. You get a big screen with all the keys, and every time when you push one key, that key on the screen changes color, and some programs even display the key code and everything, ASCII code and whatever. And I started playing because I wanted to know where the escape key was, because I needed that to jump back from this full screen animation display. Then the 4 arrow buttons. And while I was probing, so I was just connecting one of this connector to 1, 2, 3, 4, 5, 6, 7, 8, 18. And then number 2, 1 to 18, number 3, 1 to 18, until I found the corresponding pins for the functions I needed. So for example, escape key was pin 4 to pin 2, then arrow up, pin 4 to pin 8, 6 to 8, 6 to 10, 3 to 10, and accidentally I connected pin 2 to pin 16. That's this one here. So the pin numbers, I made up them myself. So I said pin 1 is here, pin 8 is there, 1, 18. So I said that is pin 2 to pin 16. That's the 2 wires here. And that turned out to be a very interesting function, because when I connected the 2 pins, my Windows 2012 server suddenly shut down without a notice, without a question. It did the shutdown procedure, screen went blank, dark, power off. So I thought, oh, what happened here? I first thought I made probably a short circuit somewhere and it crashed for some reason. And then I figured out this happens when I connect wire 2 and 16 of this board here. And it turned out this is key code 116. And key code 116 is called, well, it depends on the manufacturer. Some call it sleep mode, standby, power off, shutdown, whatever. So that means if you plug this USB cable in to any Windows server or PC, I haven't tried many operating systems, so I know it works with Windows 2012. And then you connect these two wires, your device shuts down. And it doesn't matter if you're logged in or not logged in yet, it shuts down, it turns off. We could go a little step further. We could connect the two pins here permanently, put everything together in a USB key like that, with a shorter cable of course, and then you can go to your neighbor, to your friend or to your enemy or whoever, you plug it in and that system shuts down immediately without asking any questions. Now, what happens if you connect that to a Raspberry Pi? The shutdown button has the same function, but on the Raspberry Pi in, for example, the Pi operating system, a little screen, a little window comes up and that lets you choose shutdown or reboot. So the normal reboot dialog. So you have to push a button with your mouse before it shuts down. I even tried it on the Mac here, and Mac goes immediately dark, but that's only a sleep mode. So you can hit any key on the keyboard and it wakes up again. So Mac goes into sleep mode, Raspberry Pi goes into shutdown mode, but asks you first if it should shut down or reboot or whatever, and Windows shuts down and turns off. Only with that. Well, so that's not the function I wanted, because the function I wanted is arrow down, right, left, up, and escape. And that's the schematic diagram, how to connect these 1, 2, 3, 4, 5 buttons here. I need 3 wires from J2 to 8 and 10, and I will need 3 wires from J1, 3, 6, 4 and 6, and I connect 4 here and here, 2 here, 8 here and here, and so on. And that's the way how I will connect my keyboard on this media center, and then I take USB, go to the Raspberry Pi, and well, that works. I know I could of course use the GPIO pins. Many of you will now write comments like, oh, use the GPIO pins, but with this solution I don't need to write any code, because it's just a keyboard. I press a button and exactly that happens what this button means. So I don't have to change any code, I don't have to do anything except a little bit of wiring, which I have to do anyway. If I connect that to the GPIO or to the USB, I have to rewire this part here. And I think that's the easier way for all those who don't like coding a lot.